We're surrounded by this endless universe of numbers every single day, but have you ever stopped to think about how they're all connected? Well, today, that's exactly what we're going to do. We're creating a map for that universe, a clear guide to where every single number belongs.
Think about it. You've got a negative number for a cold day, a fraction for that slice of pizza, a decimal timing your run. They seem like totally different things, right? But they are all related. And to see how, we need something like a family tree for numbers.
So, let's start at the very top. That entire universe, the giant category that holds pretty much every number you can possibly imagine, has a name. It's called the real numbers.
At the very base of it all, we have real numbers. I want you to picture this as the giant trunk of our number tree. Every other number we're going to talk about is a branch that sprouts from this one single massive source.
And right away, that main trunk splits into two huge, fundamentally different branches. This is the first, and honestly, the most important distinction in the entire system.
Every single real number has to pick a side here. It's either rational or it's irrational. There is no in between. So, what's the difference?
Well, it really all comes down to whether a number is, let's say, tidy or wild. Rational numbers are tidy. You can write them as a nice, clean fraction, and if you write them as a decimal, they either stop or they repeat in a neat pattern. But irrational numbers, they are wild. You can't contain them in a simple fraction, and their decimals just go on forever in a chaotic, non-repeating mess. The most famous one, of course, is pi, but the square root of 2 is another card-carrying member of this wild bunch.
Okay, for the rest of our trip today, we're going to leave the wild side behind and stick to the tidy, orderly part of the map. Let's follow the rational numbers branch and see where it leads us.
And inside this world of order, things get even more organized. The rational branch immediately splits again into two very distinct groups: the solid, whole-step numbers, and then all the little fractional bits that live in between.
So first up, we have the integers. Think of these as the major milestones on our map, the solid concrete markers on the number line. We're talking no fractions, no messy decimals, just clean, whole units stretching from the deepest negatives right through 0 and all the way up to the highest positives.
So numbers like -100, -4, the all-important 0, 7, or even a big one like 3,215, they're all solid, complete units. They are all integers. And if a number is rational but it isn't a solid integer, where does it go? Well, it lives in the gaps. These are the non-integer rational numbers, all of those tidy fractions and decimals that fill in the spaces.
Like 1/2, -3/4, or 0.75. They all have a very precise spot on the number line, but it's just in between those main integer steps.
We're getting really close to the very foundation of our map now. So let's zoom in one last time on the integer family to see its own internal structure. So yeah, even the integers have their own split. On one side, you have all the negative numbers, and on the other, you find this very specific, very important group called the whole numbers. Whole numbers are pretty much what they sound like. They're complete, not fractions, but they have one crucial rule. They start at 0, and they only go up. The negative integers are not invited to this party. And this brings us right down to the most fundamental level of our map. The group of whole numbers is itself made of just two parts, one very unique number and a final essential category. That unique number is, of course, 0. It's the only whole number that isn't positive. It's the origin, the starting point, the great divider. It gets its own special place because it's neither positive nor negative. It's just 0. And what's left when you take 0 away from the whole numbers? You get the natural numbers. These are the very first numbers you ever learned how to use. The counting numbers, 1, 2, 3, and so on forever. This is the absolute bedrock of mathematics.
So, there you have it. We've traveled from the entire universe of numbers all the way down to the very foundations of counting. Let's pull the camera back now and look at the complete map we've just built.
And there it is. From that huge concept of all real numbers down to the simple act of counting, everything has a logical place. It's this perfect, nested hierarchy that brings a beautiful sense of order to the entire world of numbers. Okay, time for a little test. Let's grab a number. How about -7? All right, now that you're an expert map reader, can you trace its path? Where does -7 belong?
Start from the top and see where you end up. I'll give you a second.
Let's trace it down the map together. We start at the top. Is -7 a real number? Yes, of course. Can we write it as a fraction, like -7/1? Yep, so it's rational. Because it's a solid number, not a decimal, we know it's an integer. And finally, since it's less than 0, it can't be a whole number, which means its journey ends right here. It's a negative number. See? It's simple when you have the map.
So we've put together a complete map for the real number system. But that R at the top for real, it kind of implies there might be something unreal, doesn't it? What happens when you try to take the square root of a negative number? Well, that is where a whole new incredible map begins.